Welcome to Brain Vision.
So we have a tire at 15 degrees Celsius, which has a gauge pressure of 250 kilopascals, which means its real pressure is atmospheric pressure, which is 10 power 5 pascals, plus 250 kilopascals, which is 2.5 times 10 power 5 pascals, which means it is 3.5 into 10 power 5 pascals. Now, we want to know that at temperature 38 degrees Celsius, how much of the material, how much of the air in the tire must be removed so that the same pressure is maintained. So we know the equation is PV equal to nRT. We know that the pressure needs to be constant. We know the volume is constant. And we want to change N and when T is changed. So we know that N1T1 is equal to N2T2, which means N2 is N1T1 by T2. We know that N1. So from this equation, let's find N2 by N1. That is T1 by T2. The initial temperature was 273 plus 15 in Kelvin. The final temperature was 273 plus 38 in Kelvin. This gives us 0.936, which is equal to 1 minus 0.074. I'm sorry, it was 26. That is, we need to remove this fraction of air from the tire. That is 0.074 fraction, which corresponds to obviously 7.4%. Remember that if you instead found N1 by N2, you will see that the number is 1.080, which means, N1 by N2, which means you might think that it means 8% removal, but this is wrong. The denominator needs to be the original quantity when you determine percentages. That is why this is wrong. Now, in a way to put it, now if this new tire was cooled back to 15%, then we would need to put back 8% of the current number of moles in the tire back in to maintain the same pressure. So when we are pulling out, it would be 7.4%. When we are putting back in, the same amount would be 8% because the original amount has decreased.